Hello dear students, today our topic is HDL abstraction. HDL is the abbreviated form of hardware description language. They are VHDL and Verilog. VHDL means very high speed integrated circuit. HDL, that is very high speed integrated circuit hardware description language. The different levels at which a digital circuit can be described by using HDLs are basically referred to as HDL abstraction. The highest level of abstraction is the system's level, and at this level the behavior of the system is described by stating a set of broad specifications. For example, at this level the specification can be like the computer system will perform 10 tera floating point operations per second in double precision data and consume no more than 100 watts of power. The next lower level is the algorithmic level, and at this level the specification begin to be broken down into subsystems, each with an associated behavior that will accomplish part of the primary task. That is, at this level, for example, computer specification might be broke down into subsystems such as CPU to perform the computation and random access memory to hold the input and outputs of the computation. So there is in the first level we found, that is highest level we found, it's about system as a whole, and in the second and one, that is one level down, that is in the algorithmic level, the entire system is subdivided, broken down into subsystems. Now the next level, that is just down to algorithmic level, is RTL level, that is register transfer level, and at this level the details of how the data is moved between and within the subsystems are described, in addition to how the data is manipulated based on the system input. The next lower level is the gate level, and the gate level is essentially a schematic that contains the components and the connections that will implement the functionality from the above levels of abstraction. And just below that we have a circuit level abstraction. The circuit level actually describes the operation of the basic gates and registers using transistors, wires and other electrical components such as resistors and capacitors. Finally, the lowest design abstraction level of design abstraction is material, and this particular level describes how the materials are combined and shaped in order to implement the transistors. Another graphic representation is shown over here, and this particular chart is known as Gadsky and Kunst Y chart. And here in this Y chart, abstraction across three different design domains are described, that is behavioral, structural and physical domains. Among the three domains, the behavioral domain focuses on what the system does, describe its functionality without specifying implementation details. And the second one, that is the structural domain, focuses on how the system is built, outlining the components and interconnections. And finally, the physical domain focuses on where the components are to be exactly placed and how they are physically arranged on a chip. And here each of these design domains contain levels of abstraction, that is the highest systems level of abstraction to the circuit level. Hope this class is very useful for you. Thank you for watching this video. Have a very nice day.